No matter how hard you try, you can't stop us now. We're the renegades of this atomic age. This atomic age of renegades. The renegades of this atomic age. This atomic age of renegades. Since the prehistoric ages.
Okay, section 3.1 is on classifying polynomials. Two bits of good news here. Number one, it's review, and number two, we're going to do it over 2 days. So, nice and nice. Okay, we're going to fill in this table. We have a bunch of terms up here. 7m is a term, negative 8f squared is a term, etc., etc. And we want to tell what's the coefficient, what's the variable, and what's the degree of each of these terms. But you know what would help? If we actually knew what a term is, a coefficient, a variable, and a degree. So let's talk about it. A term is a number, or it's a product of a number with one or more variables which can be raised to a power. Wow, what's all that? Okay, so let's look at this. A term could be just a number. So, for example, negative 12, that's a number. That is a term right there. But it could be more than that. It also says it could be a number or a product of a number with one variable. Ignore the more for now. One variable. So, what that would look like is a number like 5. And a product, remember what product means? It means answer when you multiply. So we're going to multiply that 5 by a variable. Let's pick, I don't know, whatever letter you want. Let's do m. So 5 times m, faster way of saying 5 times m is just 5m. So there you go, that's a term. But notice it actually says one or more variables. So another term could be something like 5mn or 5mnp or so you can have one. This means 5 times m times n times p, right? So it's a product of a whole bunch of a number with a whole bunch of variables. And there's this last piece which can be raised to a power. So all these variables here, or some of them, doesn't have to be all of them, could be raised to powers. So it could be 5m squared, or it could be 5mn cubed p squared or something. These are all terms. Okay, next, a coefficient. A coefficient is a number that multiplies a variable. So here's a coefficient. This 5 here multiplies by the m, so the coefficient is 5. In fact, the coefficient is 5 in all of these cases here. Variable. A variable is a letter or symbol. You know this. It's a letter or symbol that can represent different amounts. So the variables m, n, p, m, all these are variables. The degree, a little bit more difficult. It's the sum of the exponents of the variables in that term. So if you look at a certain term, let's do an example here. If we had something like 7m squared, then if I look at the exponent of the variable, here's the variable m, and its exponent is 2, so the degree is 2. But if it was something like 7m squared np cubed, the way you get the degree of that is you sum together, sum means add, all the exponents here. So you'd be adding 2 from the m, plus, what's on the n? What's the exponent there? 1, right? It's invisible 1 there, plus 3, so your degree of this is 6. Okay, let's go back and fill in the whole table pretty quickly here. What you might want to do is stop the video, try it, and then see if you got it right. That'd be a good way to do it. Coefficient is the number out front, so it's 7 in the first one. The number out front that's multiplying the variable in the second one is negative 8. The third one, it's 3/4. It's totally okay to have coefficients which are fractions or decimals. In this one, what's the number out front that's multiplying by d? It's negative 1. Now, in this one, I would say that the coefficient is none. There isn't one, because you're not multiplying by a variable. There's no variable in this question. And most books that I have referred to, that's what they say. And I like that. It seems to make good sense to me. Your book, on the other hand, says that the coefficient is 17. So your book says 17. I guess the reason I say that is because it could be like you're multiplying 17 times x to the 0 power. And in this case, 17 would be a coefficient because you're multiplying by variable. And anything to the 0 power is equal to 1. 17 times 1 is just 17. I guess that's the thinking here. I don't really like that thinking. You don't really have x to the 0 power, so I don't really like that. To me, this is more constant, and I think you'll see when you look at the table down here, I think you'll probably agree that it makes a little more sense to call it a constant, but your book does say that 17 is a coefficient. Don't worry about that too much. It's not really a big deal. Variable, we're just looking for the letters, aren't we? So that's easy. All I have to do is look up at the term and see what the letters in it are. M is a variable. In this one, F is a variable. In this one, we have 3 variables, X, Y, and Z. Next one, D is the variable. This one, none. There is no variable. Last one, the degree. The degree, remember, has to do with the exponents on the variables. This one has an exponent on the variable of 1. It's m to the first power, so the degree is 1. This one has an exponent of 2. This one has a whole bunch of exponents. It has a 2. It also has a 1 on the y, so we have to add that on, and a 3 on the z. So you get a total of 6. Next one, what's the exponent on that d? 1. And this one, there is no variable, so the degree is 0. Alright, great. Now we're going to do another one. We're going to fill in this table. This time we're talking about polynomials. And we want to name the polynomial, tell what the degree of the whole polynomial is, tell what the constant is, and tell what the coefficient is. So first of all, again, we need to know what these things mean. What is a polynomial? And again, it's a pretty confusing sounding definition. It's a term, or the sum difference of terms, all of which have whole number exponents, and in which variables appear only in the numerator. Wow, that sounds really complicated. So let's look first of all of things that are polynomials. Yes, these are all polynomials here. Okay, one example of a polynomial would be negative 12. It says in our definition that a term can be a polynomial. This is a polynomial. Another one could be negative 3 times x. So here we have the product of a variable and a number. In this case, it's an irrational number, but that still works. That's a polynomial. 4m cubed minus 16m. Okay, this is a difference of terms. These first two were just single terms. That's one term. That's one term. This is a difference of term. Difference means subtract. So there's a difference of terms here. There's 2 terms. That's a polynomial. And the third one I'll write down here is 2/3 x cubed minus x plus 1. There's 3 terms here. We've got a difference between the first 2 terms and a sum on the third term. So minus sign, difference, plus sign, sum. This is another polynomial. Okay, probably more important is things that aren't polynomials. And there's basically 4 things you have to look for when you're wondering if something's a polynomial or not. So I'll show you the 4 cases that are not polynomials. This is not a polynomial. Why is this not a polynomial? Because it says that it needs to be whole number exponents, and 1/3 is not a whole number exponent. Not a whole number exponent. So that is not a polynomial. Now, m to the 1/3, what does that mean? Do you remember what that means? That is the same as the cube root of m. Okay, with that in mind, the next example, very similar to this one, the square root of 3 times x. What if we had 3 times the square root of x? Is that a polynomial? No, it's not. How come? Because this is the same as 3 times x to the what power? It'd be to the 1/2. And then it fails for the same reason here. It's not a whole number exponent. So, I don't know, you could maybe draw an arrow from there to there as well to show that when you have a variable inside a radical sign, it's not going to work because it's the same as having a fractional exponent, and that's no good. It has to be a whole number. Okay, that's 2 cases which are related to each other, aren't they? The other 2 are also related to each other. If you had something like 1/3x plus 2, that is not a polynomial. How come? Because it says variables appear only in the numerator. This variable appears in the denominator. So variable in denominator. And very much related to that is the 4th thing you should look for. That's if you have something like this. 2m squared, which is fine, but then plus 3m to the negative 1. Okay, there's 2 ways you could think of this, why this doesn't work. One way is because negative 1 is not a whole number, so you know for sure that it is not a polynomial. The other way you could think of this is the same as 2m squared plus, what's this negative here? This is a flippin' negative. So this is the same as 3 over m. Hey look, you have a variable in the denominator again. So these two cases here kind of go together, and these two cases up there kind of go together. Basically, if I ask you whether something's a polynomial or not, you should look at the following. Look at the variables and see if their exponents are fractions. If so, not a polynomial. Look at the variables and see if their exponents are negative numbers. If so, not a polynomial. Look at the variables and see if they're inside radical signs. If so, not a polynomial. And look at the variables and see if they're in the denominator. If so, not a polynomial. Mostly everything else is a polynomial. Okay, now we're going to learn these terms: name, degree, constant, coefficient. Name. There's different names for polynomials, and they're very easy. Monomial. When you see mono, what do you think? You think one, and that's what it is, one term. So if you have a single term polynomial, you've got a monomial. That could be something like 7. That's a monomial. Negative 2x squared, 5xy z cubed or something. These are all one-term polynomials. Binomial. Well, you get the pattern. This is two terms. So that could be something like 3m plus 2, or 5x squared z minus 16y. These work. You'll notice that binomials, the terms are always separated by either a plus sign, this plus sign separating the two terms, or a minus sign, this minus sign separating the two terms. Trinomial. A trinomial, surprise, surprise, has 3 terms. So that could be something like 2x squared plus 8x minus 1. And again, the terms are separated by plus or minus signs, and you can see 1, 2, 3 terms. Now, all of these here are actually all called polynomials. So 7 is a polynomial, but more specifically, it's a monomial. 3m plus 2 is a polynomial, but more specifically, it's a binomial. 2x squared plus 8x minus 1 is a trinomial, but more specifically, it's a polynomial. These are all polynomials. If you have more than 3 terms, you call it a 4th term polynomial, or a 5th term polynomial, or a 6th term. They just don't have special names. Okay, degree of a polynomial. The degree of a polynomial is the same as the degree of the term that has the highest degree. Confusing? Let me give you an example. For example, if we had something like 5x squared plus 3xy cubed minus xy plus 6. How many terms? 4, right? Because we have plus sign, minus sign, plus sign. So that means there's 1 at the front, 1 in here, 1 in here, 1 here. 4 terms. So what's the degree of each one of these things? The degree of the first term is 2. The degree of the second one is 1, because there's a 1 exponent on the x, plus 3, so you get 4 there. The degree of this one here is 1, whoops, that's a 1, plus another 1, so it's 2, and the degree of this one is 0. There's no variable there. So what's the biggest number? 2, 4, 2, or 0? Biggest number is 4. The degree is 4. Just take the biggest number. Don't add them together. Very common mistake. Constant. I talked about this before. A constant is just a number that's on its own. So if we look back up here at this trinomial here, what's the number that's all by itself, that's not multiplied by a variable? -1. In this question, the term 3m plus 2, the constant, is the number all by itself, doesn't multiply by a variable, 2. Okay, let's go back and fill in the table right here. 3n, how many terms is there? Just one term, so it is called a monomial. What's the degree? Well, there's a 1 there, so it's 1. The constant, so that's the number that's by itself. You might say none, there's nothing there, but it's kind of tricky with constants. If there is none, that means you could actually say 3n plus how much? 0, so the constant is 0. Coefficient, that's the number in front of the variable, 3. How many terms here? Well, you got a plus sign there, and that separates the two terms. So if you want, you could also think you have a minus sign there. I tend to think of a negative sign, but you could also think of it as a minus, that's fine. Then you have 1 in between the highlighted parts and 1 after. So 2 terms, either way you look at it, that's a binomial. What's the degree? Well, in the first term, the degree is 2, and in the second term, the degree is 1. What's the bigger number? 2, so the degree is 2. Constant, that's the number by itself. I don't see one, so it must be 0. Coefficient, there's 2 of them, -4 on the first term, and 1. The coefficient in front of this k is 1 on the second term. Name of this one, we've got 1, 2, 3 terms. It's a trinomial. The degree, you've got to look at each term. First term, the degree is 5. Second term, the degree is 3. Third term, the degree is 0. Biggest number of those is 5. The constant is the number all by itself right there. There's no variable with that, so it's -4. And the coefficients are -3 on the first term and -2. Notice you always take the sign in front of these things. So -2 here. For the constant was -4. You take the sign in front of it. Okay, next question. 567 is just a number. It's a monomial. The degree, well, there's no variable, so it's 0. The constant is, see, this is where I think it makes more sense to call this 567. A constant is a number all by itself, and that number is all by itself. And I would say in this case the coefficient is none. There is no number that's being multiplied by a variable. But again, kind of unfortunately in my mind, your book says 567. So I'm not totally clear. Your book doesn't really ask you too much about constants. I'm not really clear if your book thinks that 567 is a constant and a coefficient, or just a coefficient and not a constant, which I would say is completely wrong. Or I don't know. I don't know really how they get around that. But I think it makes more sense to say 567 is a constant and is not a coefficient. There is no coefficient. Okay, last one. Let's look for all the plus and minus signs in this question. We have a plus, we have a minus, and we have a plus here as well. So 1, 2, 3, 4 terms. We call it a 4-term polynomial. By the way, if you're getting cute about it, for all these other ones where I wrote monomial, binomial, trinomial, monomial, what's the other name you could have written for all these? You could have put polynomial, 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 and polynomial, and really I couldn't mark it wrong. But that'd be a little cheeky. Don't do that. Degree. First one, the degree would be 1 plus 2. The second one, it would be 2 plus 3. The third one would be just 4. And the fourth one would be 1 on that y. Biggest one is the 2 plus 3, so it's 5. Constant in this case, I don't see a number all by itself, so that means the number is 0, because you could put plus 0 at the end here. Coefficients, you have a few of them. You got 2 on the first term, 5 on the second term, -1 on the third term, and 16 on the fourth term. There you go. We've done both tables. Let's move on. Last thing we need to do is evaluating polynomials. Evaluating polynomials is when a constant is substituted for a variable in a polynomial. So what are they talking about here? Well, here's a constant, which you know. You know that x is equal to -3. We're going to substitute that into the variables in a polynomial. So here's the polynomial, 2x squared minus 8x, and you're going to substitute this -3 wherever you see x. You're going to put it in there, and you're going to put it in there. So let's do that. We would have 2x, but I know that x is -3, put it in brackets to be safe, squared, minus 8x, but I know that x is -3. Okay, please don't go 2 times -3 here. You have to follow BEDMAS. First of all, look at the brackets. There's nothing to do there. Then you do exponent. So you have to do -3 squared. -3 times -3, which is 9. So we get 2 times 9 minus 8 times -3, which is -24. The other way you could think of this is, you could think of this as -8 times -3, in which case you'd be writing 2 times 9 for the first one, and then you go -8 times -3 is plus 24. That's how I tend to think of it. It kind of saves you a step. Whichever one makes more sense to you, go for it. You both get the same answer. I'll go with this one just because it might be the easier to understand how I got the answer. 2 times 9 is 18. Take away negative. Remember, when you take away negative, it's the same as adding a positive. Add the opposite, right? And so that means we have plus 24. 18 plus 24 is 42. That's our final answer. Okay, this time x is going to be equal to 3. That's our constant, 3. We're going to put in all these x's. So we have negative x is 3. I'll put it in brackets to be safe. Cubed plus 2, 3 instead of the x, minus 1. Again, do the 3 cubed first. 3 times 3 times 3 is 27, and we still have that negative there. So it's -27 plus 2 times 3 is 6, minus 1. -27 plus 6 is -21. Take away another one is -22. Use a calculator for that if you're not very good with your integers. Last one, x is equal to -2. We're plugging that into wherever we see x's. So -2, there's an x. So I'm going to put -2 squared. Plus, there's an x, -2 over 2 minus 5. Do the exponent first. -2 squared. -2 times -2 is 4. So we have -2 times 4 plus -2 divided by 2 is -1. Take away 5. -2 times 4 is -8 plus -1. Take away 5. If you're good at your integers, you can just probably get your answer right now. -8 plus -1 is -9. Take away another 5 is -14. If you're not so good with your integers, you could either change this subtraction here to a plus negative. Then you'd have 8 negatives, another 1 negative, another 5 negatives, which gives you 14 negatives. Or you could pick up that calculator of yours and do it that way. Alright, that's it. We're done. Hopefully some of that, most of it, looks familiar. If not, learn it, and next day we'll continue on with this. Good luck.
Take a man to the dance floor.